guys, this is Gurneet. In today's video, we are going to look at top 5 Python programming questions which were in particularly asked by many MAANG companies. So let's go ahead and understand each of its solution one by one. Coming to our first question, which says, given a valid IPv4 IP address, return a defined version of that IP address. A defined version, a defined IP address, it replaces every period dot with a brackets and a dot. So this is so it replaces this dot with using into this. So we have two solutions for this problem statement. First is either what we do is we treat this uh, dot as a, so we have a string, right? So we treat this dot as a separator, right? And then we split the string and then we rejoin it and we use the separator this instead of this. So let's look at the first solution. So we use split and join. So we define a function, right? A defang IP address. Then we initialize a new address. Now what we do is we split the address on what basis? Address dot split. Using split function, what we do? Address dot split using what separate? Using dot as a separator. Right now the separator is this. Now we want to use a new separator, right? So this is what the separator we are using now for a new string, right? So what we'll do is new address is equal to separator. We join the dot join split address, right? So we join it and we return the new address. So in the new address, we are using this as the separator, right? So the solution is quite simple. What we do, we what we write up our address, for example, this, and we just call our function. So if I run this, you can see that a dot has been replaced by this separator, this, right? Now coming to our second solution. So instead of using splitting and joining, what we do, we use a replace function. So it's a inbuilt function. So what we do is it's more uh, Python based. So what we do, we define a function, right? And rather than going to step by step, splitting it and then joining it, we just use a simple function, a Python function, which is replace. So what we do, we define a function, then we return address dot replace. So what are we doing? We are just replacing the separator from dot to brackets and dot, right? So instead of this, we are replacing it with this, right? So it's a very simple and it's a very Python based solution. So if I run this, you can see that I have got, so what it did, it replaced this you from this, right? So I hope the first question is clear. Now coming up to our second problem statement, which is write a program that prints the number for 1 to 50. So for number which are multiple of 2, we need to print phase instead of a number. For numbers multiple of 3, print buzz. And for numbers which are multiples of both 2 and 3, print fizz buzz, right? So now we can solve this problem statement using two solutions, right? So first, what we do, using a control flow. So as you can see that there are multiple conditions here. Either for multiple of 2, print phase, for multiple of 3, print buzz, and for numbers which are both multiples of 2 and 3, we need to print fizz buzz. So there are three conditions here. So for it's a control flow, right? So for that case, we can use a control flow that if is particular condition, then print if elif this. So it's used for a sub conditions, right? Now it's easier. So we have three conditions to check. We can write up a control flow. Now there are cases when there are number of sub conditions, like, so there are certain cases where the number of sub conditions are quite many, right? So it's impossible to just write them down. So what we do in that case, we look for our main conditions. So now the main condition here says that for number multiple of 2, or it can be a number multiple of 3, right? So first let's look at the first solution, then we'll switch to our second solution, which is what if there are too many sub conditions, right? So coming to our first condition, solution, which is the control flow. So what we do, we use a for loop for a range purposes from 1 to 50. Right. Now, if the we use a percentage operator, which means that the modulus is 0. So if it's a multiple of 2 and 3, we need to print fizzbuzz, right? Else, if the condition says that if it's a multiple of 2 only, then we print fizz. If it's a the number is a multiple of 3, we need to print buzz, right? Else we just print down the number, right? So you can see from range 1 to 50, 1 is neither a multiple of 2 or a 3, so it has just printed me the number, right? Then 2 is a multiple of 2, so it has printed me fizz. And same it goes like 3 is a multiple of 3, so it prints out buzz, and it goes by. Now you can see that multiple of both 2 and 3 is 6, 12, 18, right? So you can see that in the 6, it has just concatenated the two and not concatenated, sorry, it's fulfilling the condition that it's both multiple of 2 as well as 3, so fizz buzz, right? So it has printed me fizz buzz. Now it's quite a simple, uh, it's quite easy using a control flow. So we have used a for loop, and then we have mentioned our conditions and just gone with it. So now you can see that the range, there are in all the 6 multiple of both 2 and 3, we have fizz buzz. Other than that, we have fizz or a buzz, right? Now coming to a second solution, which I mentioned earlier. For example, what if there were a lot of conditions here? Here we just have 3 conditions, but there are a lot of cases where a lot of sub conditions are used. So it's impossible for you to write down each condition. So in that case, what we have done is we have mentioned our 2 conditions. Condition 1, which says that it's a multiple of 2, so print fizz, right? Not even print fizz, so it's a fizz, right? Condition 2, which is multiple of 3, so buzz, right? Now if condition either of the conditions are fulfilled, so if a condition 1 is fulfilled, what it does, condition 1, it will fulfill what so okay, let's look at it. Now if condition 1 or condition 2 return condition 1 into fizz, concatenate with condition 2 into buzz. So what happens is, here what is happening here is, if we are using 2 conditions, right? So if if only one of the condition is getting fulfilled, for instance, in the case of 2, right, only one condition, it is just a multiple of 2, so it will print me a fizz. But if it's a condition 2 is fulfilling, that means we are using 9, for example, right? So in that case, it's just a multiple of 3, so it will print me a buzz. But if the condition, both of the conditions are getting fulfilled, in the case of 6, 12, 18, what it will do, it is concatenating the both. So if condition 1 is also fulfilling, its condition 2 is also fulfilling, it will concatenate it and print it like a fizz buzz. So then what we do, we join it, right? Print dot join fizzbuzz function, right, for I in range 1 to 51. So we join it, and you can see that the output is similar, the same as the first one. So it is printing 1 fizz buzz fizz, 5 fizz buzz, right, and so on. So I hope this part is clear. The second problem statement is clear, that either we can use it, solve it using a control flow, or if there are like a lot of sub conditions there, what we can do, we can just mention our 2 conditions, right, and just concatenate it. Like for either of the, if either of the conditions are getting fulfilled, it will print accordingly. But if both of the conditions are getting fulfilled, it will combine it, it concatenate it, right? So I hope this problem statement is clear. Now coming up to our third problem statement, which is identify all the words that are palindrome in the following sentence. So we are given a sentence, we need to find, identify whether all the words in this palindrome, all the words are palindrome, right? So we have 2 conditions in this one. First condition is, if the same word appears multiple times, we need to return the word once, right? Condition 1. Then the second condition is the palindromes. So a palindrome sequence is what? If we have a word or a sentence, right? So what it does, words that return the same result when you read it from beginning or from the end to beginning. So in whatever manner we read up a word, either from beginning to end, or we start from the end and then go up to the beginning, right? If the result is the same, for example, uh we have many palindrome words. For example, uh lol, for example, right? Lol. So either it we read it from, in this one only we have lol, right? So either we read it from beginning to end or from end to beginning. The word is the same, right? So the word is same. So in that case, this is called a palindrome sequence. But for example, mom also, either we read it from the beginning to end or from end to beginning, the word is the same. But for example, we have this, we have not. In these cases, we do, when we read it from beginning to end, the word will be different, and if we read it from end to beginning, the word will be different, right? So I hope the palindrome sequence is clear. Now, how we will be fulfill these two conditions? The first condition says that if the word appears multiple times, we just have to return the word once. So in this case, what we will use, we'll use a set. So what a set does in Python, a set in Python, what it does, it returns it return a word only once, right? And then in palindrome, what we'll do, we have to look for many conditions here. First hidden condition is that we have to remove all the punctuation marks from our palindrome, right? So if from a word, right? So we have to remove all the punctuation marks, right? This is the first condition. Then we have to look whether the word is a case sensitive or not, right? So in that case, what we'll do, we will just either uppercase it or we'll lowercase it, so it just becomes the same. And in that case, we can just look for the whether the sequence is palindrome or not, right? So let's look at the solution. We define a palindrome sentence. First step, to remove all the punctuation marks. For in that case, we use for I for a range, right? And we mention all our punctuation marks, and then we just replace it. Sentence replace it. We can just say we are removing all of that, right? So we have removed all our punctuation marks. Then what we have done is we just replace it with blank, right? Then palindrome. So we initialize a list. So we are here using a list. First, we are initializing a list. Then what we are doing is we are using a split function. So using a split function, what we are doing, you can see that we are in a sentence. We are basically, what we are doing is we are splitting it on the basis of its white space, for the white space, or we can say just the space in between them. So using those spaces, we are splitting them, right? So split based on white space. Then what we are doing is we are iterating the list. So using for loop, we will iterate every word in the sentence, right? So word in words, what we are doing is first we'll lowercase it, right? We have lowercased it. Then what we have, the condition that we are using for a palindrome, the main sequence, the main condition which is important. The other which I mentioned, hidden conditions, which were that we have to remove all the punctuation marks, we have to look whether it's a case sensitive. These were the minor conditions, right? But the main condition, like how you solve a palindrome, is what we do, we reverse the string, right? We have a word, we have a string, right? For example, what we'll do, we'll reverse it, and we'll check if the result one and the result two is same. So in the result one, we have the string number, and in the second result, we'll store the reverse of the string. So if we reverse the string, we'll see that if both the results are same, that means it's a palindrome sequence. If the result is not the same, then in that case it's not a palindrome, right? So you can see if word is equal to, if the word is equal to the reverse. So the how will we use the reverse? We'll use the slice option. So we have, in the slice, we have start, stop, and -1 denotes that we are reversing the string, right? So the -1 means that we are using the -1 index. So using the index -1, 0, 1, -1, -2, like this. So if -1 here denotes that we are reversing the string, we are using the last index to the first index, right? So which is nothing but a reversing of a string, right? So this is the statement to determine if the if it is a palindrome or not. So if word is equal to the reverse of the word, then in that case it's a palindrome, right? Then what we'll do, palindrome is equal to append dot word, right? We'll append it, and then we'll return the set of the palette. Now till this point it's clear that we have reversed the string, we have removed all the punctuation marks, we have changed it into a lowercase, or we can use also uppercase, right? Now comes the main part. So what we have done is, we will, the second condition has been fulfilled, the palindrome one. Now we have to look at the first condition, which is if the word appear multiple times, we have to return the word once. So in that case, what are we using? We are using a set. So we'll return set. So we have converted the list. You can see that when we have initialized the palindrome sequence, what we have done, we have initialized the a list over here, but we have to convert it into a set, because we have to return only multiple words only once, right? So in that case, what we have done, we have converted our list to a set, right? So this is her fulfilling both the conditions, palindrome and the returning multiple words once, right? So now we will test our algorithm. So we have a sentence, we will just call it, and if I run this in my sentence, which is to be or not a data scientist, this is not a question, ask your mom lol. So we have to find out the palindrome sequence. So this is the word, these are the words which we have split it on the basis of white space, and it is checking it is iterating every word you in a list, right? So we have used for loop. So you can see this a, lol, and mom are the palindrome sequence. Other than that, they are not. Other words are not a palindrome sequence. So I hope this third problem statement is clear. So to summarize it, we have two conditions. For the multiple word that appears multiple times, to return it once, we use a set, right? We have converted our list to a set. Then for the palindrome sequence, what we have done, the main condition is that we reverse the string and we check if the result one is equal to the result two, if the word is equal to the reverse of the word, right? And the other hidden conditions, which is removing all the punctuation marks and converting, if it's case sensitive, then we need to convert it either into a lowercase or a uppercase, right? So I hope the problem statement is clear. Now coming up to our fourth problem statement, which is, given a string, find the first non-repeating character in it and return its index. And if it doesn't exist, we need to return -1. So now what we are doing here is, we need to find the non-repeating character, which is nothing but a unique value in a character or in a string, for example. So what it is doing is, for example, I have a string people, right? So in people, I have People, right? Each character, right? Now, if I look at each character, you can see that the count of P is 2 and E is also 2, but O and L has a count of 1, right? So we know what are the unique characters, which are uh, O and L, right? These are the unique characters. But the problem statement says that we have to find the first non-repeating character. So that is nothing but our O. So what it will do, it will return me the index number, which is in our case 2, right? So it will give me a 2 as the value. But for example, instead of this, I would have a problem string like, instead of 1 O, we could have O and L count more than 1, right? So if it would have been P, E, double O, triple L, and E, right? So the count of every character is more than 1. So in that case, it will return me a -1, right? So that means, which means that it did not find any unique character. Every character has a more count of more than 1, right? So I hope this part is clear, the problem statement is clear. Now let's move on how to solve this problem statement. So we will be solving this using the following steps. First step is, first we will create a frequency map. So what is a frequency map? Now frequency is nothing but number of occurrences a particular value has in a data or in a dictionary, array, or a list, anything, right? So a particular value, how many times it is occurring, it calculates the frequency. So the frequency map together is nothing, how many in a particular array, in a particular list, in a particular tuple, or a particular dictionary also. How many what is the what it does, frequency map, it counts the frequency of all the elements in array, list, tuple, dictionary, etc. Right? So how it does, it initializes for example, in our case, we are using a string, right? Find the first character in character means it is a dictionary, right? So we are given a string. So in our case, we are using a string. So what we will do, we will initialize a string, right? And then what we will do, for every character in string, we have to see, we will iterate it over the dictionary, right? Iterate, right? That means it will first see the first character, then the second, third, fourth. In this manner, it is performing iteration, right? So for what it will do, it will see that if the particular value or a character is already present, it's not present, for example, it's not present in the dictionary, in that case it will give its value as 1, right? But if it is already present, if that particular value or a character is already present in the dictionary that we just initialized, in that case it will increment the count, it will increment the value, the one value into, it will increment it, it will add on, right? So let's understand it using our solution here. So in this case, first we have defined our function, right? First unique character. And in this case, we have S. So type S means it's a string value. Instead of S, if it would have been R, right? So in that case, it would have been a integer value, right? This is just the explanation, right? Now we have initialized a dictionary, right? The frequency, this is our we are initializing our dictionary. Then this is our frequency map. So what it is doing is, for every character in frequency, what it is doing, for every character in frequency, it will check if that particular character is already present in the frequency. If it is not present, it will assign a value as 1. If it is already present, it will increment it, right? Using this plus, right? So using this syntax, it will just increment, it will add on, right? So this is our frequency map. So what it is doing for I in S, right? For I in S means for I in the string value, right? We are using for loop on our string, right? So if I is not in the frequency, if the first character is not present in the frequency, it will give its value as 1, right? And in the else statement, if it is already present, it will just increment it. So for example, if I consider this example, people, for the P, it is not present in the frequency because we just initialized our frequency, our dictionary. So it will add a value as 1. So P is equal to 1, right? Then coming to our second one, which is E. So again, it is not present in our frequency. It will add E, right? Then O, not present in our frequency, it will add on to our frequency. Then we have a P again, right? So in this case, what it will do, it will see it is present, it is already present in the frequency, so the count will increase from 1 to 2, right? Right? And then we move on to L, and in this manner it will just check for every character, and if it is already present, it will just increase the count, right? So our frequency map, what it will give us the result as, it will calculate it will give us the elements or the characters, and with its count, that if it's 1 or it's 2, if it's just occurring once or more than once, right? Then coming to our next step, which is to I hope the first part is clear, that we have to create a frequency map. How are we going to create a frequency map? For every character, it will give me a value, like I explained earlier. Then we come up to a third step, which is we need to scan the frequency map. And if the value of a specific, now that we have the characters and the count of the frequencies, right? What it will do, it will scan the frequency dictionary, right? And then if a particular character has a specific value as 1, then in that case it will give me the result as the key, right? But it will give me the result of its index, right? But if it is more than 1, it will return me -1 if every character has more than 1 values, right? So it is scanning the frequency map. So this step, for I in range, we will calculate the length of our string, right? If frequency of the index using index value. For example, in length, index 0, 1, 2, 3, right? So it will calculate whether every character has the specific value as 1, right? So for example, p, it is more than 1, so in that case it will just uh it will not print it, right? Because what, first it is scanning the whole frequency map, right? So it will shift over to the e part. It is also has a value more than 1, so it will shift on to the o part. So now the o has a frequency of 1, so it will return me the first character, because it is returning with the first character, right? The first non-repeating character. So it will return me the index number. But in this case, for example, we have no value which has occurrence once, right? So it will return me -1, right? So this is the scanning the frequency map. This is frequency map, and this we are doing, we are scanning the frequency map. And then what we'll do, we will test our theory now. So we have two, we have people and this particular string. So if I run this, you can see that the first index that it has given me 2, which is the correct answer. But in the second string, you can see that there is no unique character in our string, so it has given me the value as -1. So right, so I hope this problem statement is clear. If you follow it using these steps, it will be much easier. Otherwise it will be very tricky to solve this problem statement, right? So I hope it's clear. Now coming up to our last problem statement, which is every email consists of a local name and a domain name, and which is separated by the @ sign, right? So given a list of emails, we send one email to each address in the list. So how many different addresses actually receive mails? So before moving forward to the solution, first we need to understand the problem statement. Now, in the problem statement, for example, we need to first look at some rules. So for example, in Alice, this email address, you can see that the Alice part is the local name, and the after the @ sign, this part almabetter.com, it is the domain name, right? So this one is the local name and this one is the domain name, right? Now besides the lowercase letters, we have certain other these emails may contain periods and a plus sign also, which we'll understand after some time. So how are we going to solve this? So if you add periods between some characters in the local name, so we'll focus on the local part first here, right? The Alice part. If we have a period between the characters in the local name, the email will be sent to forwarded to the same, we will be forwarded to the same address without the dots. So the dot or your periods, it does not matter. That this The conclusion here is that the dot sign, it does not matter. If we have a dot in our characters, the email address, address, it will be forwarded to the same address. Like for example, I have alice.z@almabetter.com, right? And we have alice.z@almabetter.com. So if I add a dot sign also, it will be these, both of these email addresses are the same, right? So these are the same email addresses, alice.z and alice.z, it will be forwarded to the same address, right? So the local name, it does not matter. Then if you like the local name, if it has a dot sign, it does not matter, right? It will considered as the same. Then if you add a plus sign, if we have a plus sign in our local name, then after everything after the plus sign will be ignored. It won't move after the plus sign, right? So if you add a plus in the local name, everything after the plus sign will be ignored. This allows certain emails to be filtered. So there will be a filtering in the emails. Like in the previous one, there was not any filter because the dot sign, it does not matter. Like if it's alice.z or it is alice.z, it will be considered as the same thing, right? But in the plus operator, for example, if I have m.y plus name at AlmaBetter, it will be forwarded to my name. It will be forwarded to my at almabetter.com. It won't be forwarded to my name almabetter.com, because after the plus operator, everything, the name part, it will be ignored, right? So this does not apply for the domain names. It only applies for the local names. Everything these rules that I mentioned, it only applies to the local names, right? So it is possible to use both of these rules at the same time. So we will be using these rules in our problem statement, right? Now, as you can see that there are a lot of rules that we need to So to summarize it, after breaking out there, we will be left with the three parts. So we just need to focus on these three parts for solving our problem statement, right? The first is that email has two parts, local name and a domain name. That means we will be using a splitting it, right? So an email has two parts, a domain and a local name, and it is separated by an at operator, right? An at sign or operator. Then the second thing that we need to keep in our mind is for a local name, dot has no effect. So we can skip it, like skip it, or we can just ignore it. The dot operator, it does not have any value. So we cannot anything with alice dot z or alice z, it is considered the same, right? So it does not matter. The dot operator, it does not, it, you just can skip it, right? Then the thing is the plus operator, the dot operator and the for the plus operator, anything after the plus operator has to be ignored. You just leave it out, right? So anything before the plus operator you consider it, but anything after the plus operator you just leave it out, right? Then this is the second thing that we need to keep in our mind. The third thing, that the problem statement, what it is asking us to do, how many unique email addresses. So we need to find out our unique email addresses, right? So now for each step, how are we going to solve it? We will be implementing these steps into our solution. So for the first step, that means a local name and a domain name separated by an at sign. What are we going to do? Since we have a emails list, right? So we have a list of strings, as in the emails we have a list of strings, right? So what we can do, we will iterate it, right? We are going to use iteration, that means the for loop, right? And it will split using for loop. We can just split our local name and domain name into two parts, and our separator will be at sign, right? This is our first step, and we have found a solution for that. Now the second step, for the local name, dot has no effect, and the plus operator, everything after plus operator will be ignored, right? So what we can do, for the dot operator, we can just delete the dot operator from the local name, right? So the first part is complete, like the second, the dot operator has been done. Then, and we keep the original domain name, and we just replace the dot operator, or we can just delete it, right? We just replace it using a blank space, right? We can either replace it using a blank space or just delete it, right? Then, and we have to keep the original domain name, and we have to read the string up to a particular position. Why do we have to use it? Because it says that the plus operator, after everything after the plus operator will be ignored, right? We have to leave it out. So for that, what we can do, we have to find out a solution such that it will read the string only up to the plus operator, right? So the second solution is done. We have found the second solution for the second part. Then how many unique email addresses? We need to find out how many unique email addresses we have. So for that, we are going to use a set operator. We are going to use a set function, sorry. We use a set function to calculate the number of unique elements, right? So we are going to implement a third solution, third part using the set function, right? So now let's understand it using our solution. So let's come to a solution. So first step, we have defined our function number unique emails. Now we are preparing for the counting. We use our set function, right? This is the third step. We have to count the unique elements in our emails, right? So our second first part that I explained, domain, local name and the domain name, right? So we will be using an iteration. So I am using for loop, right? So for email, in emails we have to iterate our list, right? So I have divided into two parts, local and domain, and I'm using email dot split. That means I am splitting it on what basis? What are the separator that we are using? At sign, right? So it will give me a local part and a domain part. Then our first part is completed. We have split it, we are iterating it, and we have split the local part and domain part into two parts, right? Now we come to our condition part. The second condition that I explained, that if we have a plus operator, we ignore everything after our plus operator, and if we have a dot, we need to delete or replace it, right? So if plus in operator, in plus in local, since we have divided it, we have to just focus on our local part, right? So if there is a plus operator in local, we are using the slicing operator, which has start, stop, and an index, right? So we are just using stop part. So what we will do, local is equal to local dot index plus operator. So if there is a plus operator, it will stop, right? So plus operator here, the first condition, and new dot add local. So new dot add local dot replace. So we are replacing the dot operator to a blank space, or we can just delete it, right? So we are concatenating it now. So first part, the dot part has been replaced, and then we will add a add sign, and then we will add our domain, right? So this is we are joining our set. So this part is deleting our deleting or replacing the dot operator and joining the set, remaining set. So we keep our original domain name. So new dot add local dot replace, and then plus at the rate and the domain, right? Then we return the length of the new, right? So the three parts has been implemented over here. Then I just input my emails, and if I run this, you can see that number of unique emails that I have here is 2, right? Test.email plus, so I have test.email, right? 1. Then I have test.email again. So this is not a unique, this is considered as 1, right? So this is the same thing. Then bob.cathy is 1, right? And then test email plus, so this is test dot email. So you can see that this will only be considered as 1. So I will consider this as 1 and this as second. So I have 2 unique emails. That means in this list of my emails, I just have 2 emails which are the same, which are different from each other. So I have got 2 unique emails, right? So I hope the fifth problem statement, which was little tricky, but if you follow these by steps, then it will be easier. So I hope it's clear. So in this manner, we have solved all our 5 problem statements, and I hope every problem statement is clear.